Hello, everyone. Thank you for joining us. Today, our longtime customer, City of Miami Beach, Florida, will be sharing their latest drone LIDAR and imagery project aimed at developing a strategy to monitor seawalls to address ongoing city flooding. Before we get started, I would like to go ahead and do an audio check. Please notice the raise your hand button has been circled in red on the slide. If you can hear me, please click this button now. Seeing lots of hands, which is great. And I'll give everybody just a second. We still have some people coming in. Great, looks like everyone can hear me. My name is Crystal Bailey and I will be moderating today's session. Joining me is our President and CTO, Louis Graham, and the team from City of Miami Beach, Nestor Navarro and Brian Bellino. Nestor is currently the GIS manager at the City of Miami Beach, where Nestor manages the GIS division of Public Works as well as supporting all GIS-related processes citywide. Nestor is a GIS professional with over 40 years experience in enterprise GIS systems, mapping, data conversion, and information technology. Nestor's career spans 10 years in the private sector surveying and mapping, and 30 years in the public sector as a GIS manager. Nestor is currently working on streamlining aerial data collection for the City of Miami Beach with UAVs using both photogrammetry and LIDAR platforms. City surveyor Brian Bellino has over 30 years of experience as a licensed Florida professional surveyor and mapper in both the public and private sectors. Brian has extensive knowledge with Florida standards of practice, legal aspects, title boundaries, GPS and LIDAR technologies, and much more for surveyors and mappers. Thank you both for joining us today and sharing your project with us. Before we begin, I would like to go over a few things. Group audio has been disabled for this session. If you would like to ask a question, please use the question box on your GoToWebinar panel. This session will be roughly 60 minutes. If we do not get to your question during this webinar, we will follow up with you by email. This webinar is being recorded and will be distributed to everyone registered. At this time, I'm going to launch one poll question to get us started. Please indicate your use of drone mapping inspection technology. Check all that apply. And I will be sharing these results with everybody just to get a good idea of our user group with us today. Leave that open for just a second longer. Still got some votes coming in. All right. We'll go ahead and close that poll and share those results with everybody. Looks like we have 57% performing photogrammetric mapping using drones and 39 doing both LIDAR and photogrammetric mapping. So that's great. Awesome. So I'm going to go ahead and close that out. Thank you all for voting. Joining me now is our President and CTO, Louis Graham. And while Louis shares a few notes, I will pass the presentation over to Nestor.
Good day, everybody. Thanks very much for joining us, and especially our presenters from City of Miami Beach. When we first came out with the TrueView 410, it was a brand new technology that integrated LIDAR with cameras. We were pretty excited about it. And along came Nestor from the City of Miami Beach with this very ambitious project. And I was thinking to myself, oh, couldn't our first customer just be doing 20 acres of topo? Instead, Nestor had this plan to do, I think, around 60 linear miles of seawall. So quite an ambitious project. And I'm just pretty amazed at the way all of this came together for the City of Miami Beach. Our part of it was just to supply hardware and software technology, but the vision and the execution and all that was the city of Miami Beach. So we're really pleased that they're able to share that with this group this morning. Turn it over to you, Nestor.
Well, thank you, Louis. Much appreciated, and thank you, Crystal, as well. And for everyone joining us this morning to let us share our experiences with using UAS technology to map the seawalls within the city limits of Miami Beach. So I'm going to go ahead and just get started. So this process we started back in 2019, and I'm going to just kind of touch on these different categories, with number one being the background, number two, the logistics, number three, the data collection, number four, the prioritization, number five, the mapping, number six, the GIS demo, which will show the interactive GIS. The number seven, discuss ongoing projects, and at the end, we'll take some questions and answers. So a little bit of background. The city of Miami Beach has always been investing in aging infrastructure to reduce flood risks and also adapting to climate change. And we've been committed to building resilience on several fronts. So over the last few years, the city has updated its land use code development regulations for new construction in order to address stormwater retention, setbacks, and increased base flood and freeboard elevation. So recently we adopted an ordinance entitled Resiliency Standards for Tidal and Flood Protection, which basically requires all new seawalls and the reconstruction of existing seawalls that are in disrepair or causing flooding on adjacent properties and public right-of-ways to be constructed to a minimum elevation of 5.7 feet in AVD. And all the elevations I'll refer to moving forward will be in AVD. So the city has approximately 55 miles of seawalls, and out of those 55 miles, 50 miles are privately owned, where 5 miles are city-owned. So to date, the city of Miami Beach has already reconstructed approximately 1 mile of seawalls. 0.2 miles of seawalls are currently in the design phase, and 1 mile of seawalls are either under construction or under procurement to be constructed. So that left about 2.8 miles of city-owned seawalls that require reconstruction. And this whole process that we went through is revolving around those 2.8 miles of city-owned seawalls that require reconstruction. But also, we needed to collect all the data for all the seawalls in the city to be able to do an accurate assessment of what we needed to do to move forward. So under the direction of the City Commission, Public Works, and the Sustainability and Resiliency Committee, we were committed to conducting research to bring back a bunch of options for assessing the seawall elevations within the city. So Brian and I got together and we looked at all the options that were currently available, and we came up with 4 options, where at the end we chose an aerial system, a UAS with LIDAR, to perform the data collection in-house. And this selection allows us to reduce our costs, achieve the best quality, and avoid needing to access private properties, which is a big concern here in Miami Beach. So together with the survey division, we did a topographical survey of all the city-wide city walls, and to come up with a reliable mean elevation for each seawall. And that was going to be the main parameter that we used to perform this evaluation. We also incorporated the property appraiser's data for all the parcel information to verify the lengths of the seawalls, and to also identify which are the private and city-owned seawalls as well. Then we took all that information, and together with engineering, we developed a methodology to rank and prioritize the reconstruction of the remaining 2.8 miles of seawalls, to do it all within the next 10 years. But it wasn't just simply figuring out what the elevations of the seawalls were and just saying, okay, we're going to take the lowest. We had to figure out the elevations, the locations of those seawalls, the condition of the existing seawalls. All those factors had to weigh in to rank the seawalls that needed to be either reconstructed or built. And then further adjustments to the initial rankings were made to account for the overall benefit due to contiguous private seawalls and the ability to promote and encourage neighbors to reconstruct their seawalls and join the city in this resilient efforts to create a continuous barrier throughout the city. So basically, in a nutshell, rather than just looking at our own seawalls, we looked at all the adjacent seawalls to ours, just to take into account the condition of those seawalls as well and the elevations, and come up with a plan that takes all those other private seawalls into account as well. So back to the options. Again, we came up with 4 options, and the first one was a consultant performing aerial LIDAR. And you can see here on the slide the pros. We have a lot of pros. The high density point cloud, we can obtain the data on the top of the seawalls. Accuracy is good. Weather and tree canopies are not an issue. We can export DEMs, DTMs compatible with GIS and CAD, and not a whole lot of staff time needed for the project. Now the cons were that we need to place targets on private property, and that's an issue here in Miami Beach. We just don't have a lot of access to private properties, and there's a lot of private property compared to city-owned properties within the city limits. So personnel will need to access docks and seawalls to set the targets. And then in the end, the hardware and the software is owned by the consultant, not the city. So that was a factor. The second option we looked at was using boat LIDAR. Basically the same pros as the aerial LIDAR, but the boat LIDAR had a lot more cons, basically because we're getting more of a profile of the elevation line of the seawalls. Just the very top of the seawall, but not very much into the property. The terrain model is only extracted on the seawall, so again, we can't see data back into the back of the property. Docks and boats can obstruct the data return. Targets still need to be placed on private property. Deliverables just didn't meet our engineering needs. And again, the hardware and software is owned by the consultant. And we looked at the third option, which was, at the time, we had an existing Matrice 200 with a Loki GNSS positioning system on it that we have been using for photogrammetry. And we said, well, we could use that. But again, we had some cons where you can only fly during clear weather, which is not that big a deal. Obviously, we can just wait till we have clear weather. But we have the issue with the tree canopies. And a lot of these seawalls within the city just have a lot of vegetation coverage. That was probably the biggest obstacle we ran into. You needed multiple flight passes, and the post-processing time is long when using the photogrammetry method. And then the fourth option we looked at was obtaining our own UAS with a LIDAR sensor to perform the analysis, and the pros just outweighed the cons. Everything we were looking for could be delivered using that system. So that's, in the end, that's the recommendation we made back to the committees, and they agreed, and we purchased a LIDAR sensor and drone and moved forward with the project. So a little more background. The city started with a Phantom 4 Pro, but we attached a Loki GNSS positioning system on it for higher accuracy. And initially, we were doing things like construction monitoring, taking videos of all our construction projects before, during, and after. Obviously, we do a damage assessment as well before, during, and after storms, so we could catalog damages, turn over to FEMA, and so forth. We assisted in search and rescue. We still do every year with the fire department. We train as well. And with the positioning system, we started looking at doing some photogrammetry with the survey department and using the Phantom 4. Well, since that started to pay off and we saw the benefits of using photogrammetry with the UAS, we moved up into the Loki the DJI Matrice 200 with the Loki, which is a lot more stable platform that allowed us longer flight times, cover more area. And we started doing a lot of photogrammetry, exporting out digital terrain models, contours, 3D models, doing change detection, a lot of before and after the storms on the beaches, and to look at the volumes of sand that was washed away or lost, etc., that kind of stuff. And then that brought us to the current project, which is the Seawall project and the LIDAR UAS that was needed to move forward. And at the time, we were researching all these different sensors that were out there, and definitely there was quite a few to choose from. But one of the options was no one really had an option with a built-in photo sensors. You had to take existing photo systems and mount them, and it was complicated. And you had to, the processing to sync up the photos and so forth. And just at that time, Lewis's group had just come out with the TrueView 410 imaging system, which had not only the sensor, of course, but it also has dual 20 megapixel cameras built in, so that as you're flying and collecting the LiDAR data, it's also taking the images, the photos, and all that is being synced up at the same time. And as well as allows you to take those images and colorize the point clouds, which I'll show here in a few minutes. So you basically had everything in one unit, and they had just come out with the unit, and we said, this looks like the way to go, and we said let's try it and let's do some testing, and we did some testing and it worked out, and we said let's move forward with this unit. So moving into the logistics, it took a lot of collaboration for all of this to come together. Besides the GIS department and engineering, public works in general, we had to collaborate with the survey division, Brian's group, in order to meet the regulations for aerial mapping and surveying. Of course, for the accuracy guidelines, the GPS ground control points needed to be set before each flight, verifying the benchmarks and the accuracy of each flight. And then as well as we had to coordinate with the fire department, which already had an existing certificate of authorization issued by the FAA, so we could fly under that COA. And of course, we also had to abide by the FAA flight rules with the pilots, me and myself, using remote pilot license to abide by Part 107 federal regulations. So I'm going to touch a little bit on all the logistics, and this is where we moved into the record survey report and map that Brian and his group put together. Basically, Brian outlined all of the items that we needed to present as part of this project. And I'll let Brian go ahead and discuss this a little bit further. Brian, good morning.
Hello, everybody. Thank you, Nestor. Well, first off, I'm just going to talk about the screenshot you have up there now, where it says the elevations have approximate vertical diameter of 0.05. Well, we met that easily. We are actually within 3 inches or 2.5 tenths in LiDAR data. And you probably ask, well, how do I know that? Well, I'll explain that to you in a second. But all this data, all this text that you see on the screen, when Nestor shows you the GIS interactive map, this is a outline of what's previous to that GIS map. So people want to know what the accuracies that are attained, or what we followed, or any of the parameters of how that GIS data was developed by survey means. This is your opening document. In order to go any further into the document, you have to accept it as if you were going on any other website and read their disclaimer of what their information is. So you know how that goes. Most people don't read it anyway. They click through it and go through. But if you really want to know what was achieved and what the outlines were of of the information, this is it. This is a survey. This is a surveyor's report, basically, that goes with the digital copy of this survey, which is the GIS now. Now, back to the accuracies is all this sounds great, right? We have this fancy drone with this fancy LIDAR, and all this all should work out fine. Well, a lot of people are skeptical about that, and so my job was more or less to give a confidence level to the data that we're getting with the information that the LIDAR was providing, the drone was providing, and Nestor was gathering. Well, how we did that was, fortunately, we're partnered with the FDOT. They have a continuous operating station, a core station for GPS here at the city that we were tied into. Both Nestor and I were tied into. I was on the ground with the RTK GPS, and of course Nestor's up in the air with the drone. Well, then we took that information and compared it to actually conventional benchmarks that we've had throughout the city. These conventional benchmarks are done just that, by conventional means with survey level and rod, where years and years of setting points and maintaining this network. So we had a good ground network, ground controlled network, with elevations done by conventional methods. So that being said, we have two good things going for us. We have a benchmark system throughout the city that's over 100 benchmarks that we could readily check into, as well as a state-of-the-art GPS from the FDOT, this core station. So what we did with that information we had is we got on the ground and we put down ground control points for Nestor to tie into when he was flying. These ground control points were basically done both ways, with conventional and with the RTK GPS. In the end, since the area we're getting such good accuracies, in the end we decided, well, with the tolerance we're trying to achieve, we're doing this. This is working out just fine with the RTK. So we use the RTK, but we sure didn't forget about checking into actual physical benchmarks as we were setting these points. So we set points along the flight paths for Nestor to check to, well, when, with his point cloud. So in the end, we had a ground XYZ, and Nestor obtained an XYZ from the air. So we compared the two, and it gave us our reports and our tolerances. And there was very few cases. We weren't perfect, but there was very few cases that we had to go back and adjust. Something wasn't quite right. But there was a lot of forethought given into this. And in talks of the data that we had as far as GPS and benchmarks, I've also had private data from private surveyors that did private work on private property for people that were here, redoing their seawalls. And so we had plans for seawalls coming in the office, and the end result of those plans was required as an as-built survey, an NAVD 88. So we had somewhat of a database by even third-party surveyors to compare what Nestor was getting with the LIDAR and what a third party is getting. So we even had a third check for all this. So that being said, we had the as-builts, we had the RTK, we had the FDOT, we had benchmarks, and we all sewed it all together. And this is the end result, what you're going to see with Nestor's proof can show you. And it is something. I mean, it is really something. And Nestor did an excellent job and was very thorough. And with that, to end, Nestor, I'll turn it back over to you.
Thank you, Brian. Appreciate it. So there's everything that, in a nutshell, what everyone needs to, if anyone needs information on all the little pieces and parts and accuracy, it's there, and it's also on the GIS site. But let me go ahead and move forward. So again, the logistics of fire department, we coordinated to make sure we're flying under the existing COA. We met the FAA regulations with Part 107. And then we moved into the data collection process. And from start to finish, every one of these flights, this is basically all the steps that we needed to generate outputs, including identifying the mission areas, doing the flight planning, setting the ground control points, conducting the flights. Now the flights, we said we had 55 miles of seawalls flown, but remember we had to fly one direction and had to fly back, so we basically flew over 100 miles with the drone. We did the point clouds generation, and we have over 1.1 billion LIDAR points were processed. We would generate orthophotos, DEMS, digital terrain models, contours, 3D models, 3D profiles. All these were as needed, and we didn't do them for every flight, but in cases where engineering or someone in public works needed any of those outputs, we would be able to create them. And then we got into the elevations extraction, where we had to individually, or I had to sit down and basically digitize over 2,500 seawalls individually to extract the elevations. And I'm going to touch on those in a minute. So the first part of, obviously, was identify the mission areas. This is just an example of a finger of one of the areas on the northwest side of the island. And then we did the flight planning, where I had to sit down and plan every flight. You have to take into account, obviously, the elevations, your distance, your batteries, your weather condition, file the flight plans. All those items you have to take into account. We would fly in the mornings. We had enough battery packs to fly in the morning, and then come back and start processing data in the afternoon. But also, as you can see here on this screenshot, we'd make sure that all the flight plan was visually accurate, that there was no obstacles, that the altitude, everything was set correctly before we went out. Brian and his crew would come in and have the GPS, the ground control point set, the elevations prior to our flights. And then we started conducting the flights, and the screenshot just kind of shows you all the areas that were covered. And again, some of the corrections or the verifications of the flight paths. Then after the flights, which was really the easy part, was the data collection, processing of all that data. So as you can see in this screenshot, we would take and generate the point clouds. And besides just generating the point clouds, we would, again, do the verification with the elevations, with the ground control points. The image on the right shows you the advantage of the 410 sensor having the photos taken as well at the same time. You can colorize the point clouds and see it that way. And we also had ground classify. So I would take all that data and ground classify it to grab the data along not only the seawalls, but into the parcel. And then there were cases, like I mentioned earlier, that they might have wanted ortho photos generated. We would generate ortho photos, generate digital elevation models, generate digital terrain models, generate contours, and generate 3D models for those that needed in engineering. They wanted to try their hand at bringing some of this stuff into CAD in a model format. We generate our 3D profiles right from the LIDAR if we needed to examine some of those seawalls closer. And then we got into the extraction. And with the help of Lewis's group, they designed a tool for us that we could digitize each seawall, the top of each seawall, and it would automatically extract the minimum, the maximum, and the mean of those areas that we were digitizing. Now, as you can see from this image, again, and as I had stated earlier, there's a lot of vegetation on all these seawalls. I mean, it's very, very, very dense in a lot of the areas. So even the LIDAR, being that it could penetrate a lot of the vegetation, in some cases it just couldn't. And in some cases it gave us readings that were not consistent. And, in a perfect world, the seawalls would be all flat, there'd be no slopes. and you're good to go. But there was a bunch of seawalls where we took all this data and sat down with engineering and came up with some formulas that we took back to GIS to have it run through the system and come back with seawalls that were out of a certain tolerance, whether it be in elevations between one and the other and slopes. So once we flagged all those seawalls, I had to go back and examine. It came out to a little over 800 more seawalls. I had to go back and individually look at them again to make sure that the data we captured was correct. And again, we re-examined those, looked at the profiles and everything, and made sure that all the data that was collected met within the tolerances that engineering had defined. So then we have all that data, and the next step was to prioritize which seawalls needed to be reconstructed, refurbished, etc. But again, it wasn't just simply going by the lowest elevation of the seawall. We had to take a lot of factors into account. One was the elevation, but then we needed to take into account the locations of the existing seawalls, the conditions, the contiguous, and then assign the rankings. So the first part was the elevations. So we had to come up with the accurate mean elevations, and which we did. Then we needed to take into account king tides. Here in the city, we get king tides that are above 2.3 feet, basically over a foot higher than normal. And this is on a sunny day. We get street flooding because you have seawalls that are way below 2.3 feet. So we need that to have to be taken into account, that just raising the seawalls wasn't going to help, everything right away. You got to take into account king tides. You got to take into account storm surges, king tides in combinations with storms. All those items had to be taken into account. So based on those evaluations of just the elevations and the king tide, the 2.3 feet, we identified 66 city-owned seawalls that required raising. And as you can see in this photo here, this is just a sunny day flooding from king tides. But one of the first, besides the elevation analysis, we had to do locations, and we had to take into account the seawalls that are adjacent to roads that are used for emergency evacuations. So those roads and those seawalls are given a higher ranking than the ones that are just in residential neighborhoods or in street ends, because obviously we need to make sure that those roads are always going to be clear with storms moving forward. Then the next step was to take into account the condition of the existing seawalls, where you can see in a photo here, some are just, they needed to be repaired right away just because of the condition of the deterioration, whereas others could still, hold their own for a few more years. So we had already done, back between 2011 and 2015, visual inspections and on all the seawalls and catalog their conditions. So that was part of the assessment, was the conditions of the existing seawalls. So we have elevation, location, and condition. Then we took the next part, was take the contiguous seawalls. And basically it just means that we took the city seawalls that we know we needed to repair, and we went out at the adjacent to each seawall, left and right, put all this in the GIS, and had the system start going out in each direction until it hit an elevation of 5.7 feet or higher. So basically what we didn't want to do is raise a seawall to 5.7, but on each side of it, you have private seawalls that are below, 2 feet, and you're going to get all that flooding anyway. So we needed to start analyzing all the seawalls, all the adjacent seawalls on each side, to take into account if we can approach these private owners and say, hey, we're going to help you, let's raise your seawalls to get everything within the 5.7, so that all this, neighborhoods don't flood. So that was the next factor, was looking at all the adjacent seawalls from the ones we plan to raise. and that was another part of the ranking. So then we moved into the ranking. We had the 66 city-owned seawalls that were identified needing reconstruction. And we said, let's divide them up into 5 groups with a 2-year cycle for each group. So the whole program can be done over 10 years. And that was taking all the items that I mentioned earlier. We identified the 66 seawalls and ranked them accordingly based on all the conditions on which ones needed to be done first and which ones could wait out to the 10 years. Then we moved into the mapping portion of it, where we basically had 2 parts to develop, was obviously the hard copy maps and then the interactive GIS. So the hard copy was simply this. We created a map showing all the prioritized seawalls with their ranking locations, and that's again can be adjusted at any time based on conditions changing on seawalls moving forward. So now we had a base to work with. And then the next part was to take all this information and create a site. We have many sites within the city of Miami Beach. This is one of them that I created to put all this data in so that staff can look at any time for further planning and functions and analyzing. So I'm going to jump over there real quick and show you a demo of it live. And this is the site when you first go in. And as Brian mentioned earlier, we have the basic disclaimer, and the user can go in and look at the record survey and map that all the information that was provided earlier that he pointed out. But once you go into the GIS, the users can now see we mapped all the elevations of each seawall. I mapped everything towards the parcels so that you could easily, quickly look and see what's going on with the elevations throughout the city without having to zoom in and just try and look at the parcels. They're broken down. You have the mean, you have the max, and you have the minimums. And the user can just simply click on any of them and pull up all the information, the addresses, the elevations, links, owner. By using the property appraiser's data and our data, we identified or tagged each parcel with the type of seawall it was, the jurisdiction, and the status, if it's existing, under construction, design, etc. Besides looking at all the seawall information, we set up custom filtering, but user can go in and filter by elevations. In this case, I'm showing that we want to see everything that's 2.3 or below. Then you can quickly just filter out and see all those individual seawalls. And I don't have that turned on there. There we go. We have the jurisdictions, as I mentioned before, so you can see who owns what. The user can go in and look at the segments that are the prioritized segments. And you can see here the costs for those segments, the scores, the rankings, everything's there. And then the runs, as I mentioned earlier, was where we used the assisted GIS system to identify between the seawalls that needed to be raised and how far out before it hit a 5.7 on each side. We also have the control points are all there with all the information, the flights. Maybe. There we go. The flight areas that were covered. And we also added the dam information gathered from the LIDAR. Give me a second here to load up, so there you have it. So it gives the users and the staff quite a good tool to go in and look at areas throughout the city as they need to when it relates to the seawalls. So I'm going to jump back over here. And oh, apologies. Back over here. Okay, and move forward. So I just went through the demo real quick. We did elevation analysis, the prioritizations, the filtering, terrain models. And our ongoing projects include, we're doing bridge inspections, features, extraction, impervious surfaces, and looking at getting into hyperspectral imaging here to look at our waterways more closely with stuff that may be contaminating our waterways. And that brings us back over to Crystal. Thank you everyone for joining us for our presentation. I appreciate it. And Crystal, back to you.
Thank you so much, Nestor and Brian. That is such a cool project, and it's really awesome to see, you know, the start of its inception and then a final product. So it's very interesting, and thank you for sharing that with us today. Before we start jumping into our Q&A portion, which Lewis, if you'll help facilitate a few of those questions that come through, I'm going to take over the presentation and launch one last poll question. So I'll share my screen really quick. So let me launch this one poll question real quick. And it's simply, what is your interest in the TrueView solutions? You know, if TrueView doesn't fit your needs, we would love to have a conversation. Please feel free to email us at info@goq.com with further details, and we can go ahead and answer a few questions while we let this poll run.
All right. Can you hear me okay, Crystal?
I sure can.
Yeah, so a few questions have come in during the presentations, which, by the way, Nestor and Brian, was great. I really appreciate that. One of the questions is interesting on the from the point of view of drainage infrastructure. So you're raising seawalls. Is there an effort that needs to come along to change the drainage?
Yeah, I'll answer that one, Nestor, if you don't mind.
Okay, perfect. Yes.
The city is doing several things that are trying to, you know, help with the drainage woes that we have. I don't know exactly, maybe Hester will remember, but we're installing these massive pump stations to pump this water out. But, you know, we're raising the roads also. And so we're doing this. There's so many different facets of this global warming and tidal flooding and ponding is just unbelievable. So this is definitely just the tip of one of the things that contributes to the flooding. And Nestor, didn't they say there's something like 80 these pump stations, something like that?
Yes, that's a ballpark. We're new raising roads, new drainage, complete new drainage systems, and pump stations and generators, and all that is being done throughout the city. And that's one of the ongoing projects, Public Works.
These are not no small pumps either. They're huge. The pipes that are leading to and from going 6 feet in diameter. So.
Thanks. There's a question on how did you decide on the design, you know, the new design height of seawalls? You know, did you do some projective modeling, and how far out do you think that takes you?
That was done by engineering. I can't say off the top of my head. It was done they did do modeling to project out to, and I may be wrong on this, I would say 2050, but I don't have the numbers in front of me. But the resiliency department, engineering, public works, they all got together and did put a modeling out to X number of years, and we can provide that if you need it, in order to come up with that 5.7. Because yes, obviously, you can go out further, and you can. It's all a matter of money and time, and we say we want to go out 100 years. Well, where are we going to be with how high we need to raise? But they did do modeling and so forth, and that was done way back prior, obviously, to this project being commenced. But we can get you, if anyone needs that data, we can obviously put that together for you and let you know how we came up with that number.
It was actually raised. It was at 3.2. Then another study came along and they said, well, 3.2 is not good enough. It's going to be at 5.7. And that's usually done on the engineering end. I think our city engineers, in collaboration with other people, came up with that number.
There's a couple questions on, when you were talking in the beginning, Nestor, about the trade-off and cost analysis. So there was a couple questions just on, what were the ratios when you looked at the different, the one difference or?
Yes, just to give you an idea, the aerial LIDAR we were quoted in the over $400,000 range for doing the citywide, and they were all way above the boat LIDAR was almost $300,000, $200-something thousand range. In the end, the LIDAR, our own LIDAR drone, ran us around $100,000. So the rest was just our time, staff's time to do the project. So that was kind of like a big difference there.
Yeah, another question on, did you have any pushback or interaction with property owners that were worried about drones flying over their property, or even more so than that, you were out figuring out ways that they needed to spend money?
Well, let me say this. Before we even, I've said this before, and before we even thought of putting a drone up in the air, of course, we have a legal staff here at the city, and we had an opinion provided on the deployment of drones, and based on the Florida statutes, and he gave us, our legal department gave us the authorization, so to speak, of their interpretation of the law. And basically, as long as we followed the FAA rules, the drone could be deployed under the provision for mapping and by professional surveyors. So that's where it was deployed under a provision of, when drones first came out, there was a House bill that got presented, and it ended up getting passed that for surveying purposes, drones can be deployed and in government agencies also. So this was well thought before we even, because we have a lot of particular people here at the city, and yes, that was a very big concern before we even put the bird up in the air.
Yes, and a touch on that, thank you, Brian, was that keep in mind all our flights were done over water. Technically, we didn't fly over any seawalls directly. All the flights were done over water to collect the data of the seawalls and the property, and at no point did the drone hover over anybody's property or near anybody's property. They just flew the flight paths and over the water and back. So we avoided flying over anybody's property just in case, so that just to add that added security.
I think you may have mentioned this, but is the city requiring private property owners their seawalls to the minimum level?
Not at this time. Well, let me back up. It's being required when they do a new construction or a refurbishment. Yes, then they're required to be at the 5.7. But existing owners, other than that, are not required to raise to 5.7. But because of this project, and because we were able to gather the data for all the seawalls, now staff and administration can approach private citizens and with the data and see options that might be beneficial to them and their neighborhoods to have them raise their seawalls and look at options and how the city can assist in doing that. So that was one of the reasons we needed to collect the data for all the seawalls, not just the city seawalls. We wanted to be able to have accurate data that we can go back to the private owners and show them what's going on with them and their neighbors.
So what's next? So you've done this massive seawall project. What do you have on your plate to do next?
Well, again, we looking at other options for using the drone out, putting it more used for construction planning and engineering and design. So we have flown some neighborhoods with it, and hopefully we'll be able to fly some more and use it for more mainstream analysis when it comes to designing and engineering. Again, as Brian mentioned, we're raising roads throughout the city, and the unit is very valuable in collecting the data, existing data there, and modeling it to see what's involved in planning and construction moving forward. So that's probably the number one priority with that. But there's other uses, as I mentioned, with hyperspectral imaging that we've talked about maybe using for analyzing our waterways. And then who knows what else is out there. We've got enough to keep us busy between that, the flooding, the beaches with our erosions and storms and stuff like that. So we got plenty on our plate to keep us busy using the drones for gathering data.
Nestor, could you mention too what kind of angular? You don't have to be right over the feature, correct?
No, that and the reason, yes, we flew basically just a rough estimate. It was about 150 feet altitude, to 50 feet off the seawall over the water, so that we could capture not only the top of the seawall and into the property, but the face of the seawall as well. So that's the reasoning on why we flew over the water, just so that we could gather more data and also help with the penetration of the vegetation onto the surface of the seawall, because that's again the biggest problem we have here is there's just a ton of vegetation covering these seawalls, and it would have been nice to just be able to do it all in one pass and digitize it once and come back with clean data. But no, that because of the vegetation, we had to go back and look at it again closer. But it's just part of the process. Someone or areas that don't have any vegetation to worry about, then you're golden. You're going to get the data nice and clean and right the first time. But when it comes to vegetation, and even with the penetration, you still need to double check your analysis, your data.
Are you currently doing any bathymetric work, and have you considered using bathymetric?
I'm not, the GIS division's not. Brian, are you doing anything bathymetric wise?
No, not really. I mean, that's still, I know that they have the little sounding units that they go on the boat, but no, we really haven't gotten into that yet. But we may be, because, you know, we're looking at some of our subaqueous utility crossings right now. So, you know, that might be in the future.
We had a question on, you know, what was the timeline? Did you ever compute just, I know we had a lot of interruptions in the COVID and, you know, and other reasons.
All in all,
Computationally.
yes. Thank you, Louis. Yes, all in all, the whole project got completed within, I would say within, if you were to put all the time, the flying and the processing, within a 6-month time period. Even though that wasn't the case in actual time, only because we started in early 20, and then I had an accident and put me out of commission for 8 months. So we didn't pick it back up to early 21. So, but basically, if you take the contiguous time, it was around 6 months. We were able to do it from start to finish. The planning, the flying, the processing, the mapping, you know, the prioritization, all that. Around a 6-month time frame. We were hoping to do it within 4 initially, but you know, there's other factors, and it just came out to be around 6 months.
Still seems pretty remarkable to me. It's a large project.
Yeah.
Clients using our systems, and yours is definitely on the very large side. So anyway, congratulations for that, a terrific project. And I really very much appreciate both of you, Nestor and Brian, doing this presentation for us. Covered all the questions, and yes, we will make the presentation available. And Crystal?
Yes,
Any
before
final
we
comments?
go, we did want to announce our next webinar, which will be held Monday, November 15th. Here at GOQ, we've been working on a number of exciting projects. And in this webinar, we will introduce some recent developments, including software workflow developments in our point cloud processing software, new product offerings, and hardware updates. So we will be hosting this webinar at 2 different times. So be on a lookout for a link to that webinar. So that you can keep up to date with everything we got going on here at GOQ. I want to again, of course, thank Louis, Nestor, Brian for joining us today, and everyone who's attended. This webinar is being recorded and will be distributed to everyone registered, and we will hope to hear from you soon. So have a great day, everybody.
Thank you, Crystal, Louis, Brian, everyone for attending. Thank you very much.
Yes, thank you, everybody. It's Brian.
Thank you. Have a good day, everybody.
Have a good day.